The following is an original production of AZPM News.
This week on Arizona Illustrated, we'll introduce you to scientists who are trying to unlock one of the biggest secrets in the universe on a remote sky island in southern Arizona.
If dark energy is constant, it means that the dark energy is the same, which means that the acceleration of the universe expansion would continue forever.
With spring right around the corner, before you start planting, learn about a native tree that will thrive in your yard.
It lacks thorns, so it makes an ideal street tree.
And take a trip to northern Arizona to meet a traditional Kachina Doll carver.
Well, this is all part of nature doing this type of artwork.
Hello, and welcome to Arizona Illustrated. I'm Tom McNamara, and we are joining you from the Kitt Peak National Observatory about an hour west of Tucson off Ajo Way. This beautiful sky island is home to one of the largest collections of telescopes in the world. The University of Arizona is home to the National Science Foundation's NORLab, the United States headquarters for ground-based astronomy. Now, their windows on the Universe Center for Astronomy recently opened to the public, and it's the first science center in the world built inside a telescope, and we're going to be telling you all about that. But first, we'll show you how astronomers here at Kitt Peak are using one of the most powerful telescopes in the world called DESI to give us an unprecedented, detailed map of the universe. And they're using it to unlock the secrets of dark energy, which is a mysterious force that's speeding up the expansion of the cosmos and shaping our view of the universe.
I think that people, just being human beings, are curious. We want to understand in what universe do we live? How is it shaping, evolving? What is its future? What is the fate of the universe? It really comes down to a very, very fundamental question about our place and where we live.
We establish a cosmic context for mankind.
Humans have always wanted to know what their surroundings look like, and telescopes provide the ability to do that.
It's one small step for man, one giant leap for mankind.
This work is a way for us to learn about our one universe. So what is its future? What is its fate? Walking into the dome to see the telescope itself is always a feeling of a bit of awe. One thing I really like to do every night that I go observing is to make sure to watch the sunset, but also look at all my surroundings. You know, it helps to add some perspective. I think going in person observing is important to also kind of remind ourselves of our place in the universe. So to me, observing is not just gathering data, it's also an experience, like as a human, and it's also a connection to the universe. So an observing night doesn't actually start at night. It even starts earlier in the afternoon because we have to take a number of calibrations. So we have to characterize the instrument's property, the optics property. Hey guys, everything good? There is that feeling of being an explorer because sometimes, you know, I start getting ready to work and I think, oh, maybe today I'll find something that I'm not expecting. DESI is a Dark Energy Spectroscopic Instrument, and it was built at the Lawrence Berkeley Lab in California, and then it was mounted in the telescope here on Kitt Peak in 2019. And it was built specifically to conduct what is called a stage 4 dark energy experiment. One of the biggest mysteries in astronomy right now is dark energy. Dark energy is the name that was given to the phenomenon of the expansion of the universe happening at an accelerated pace. It's this force that's pushing everything apart. It's stretching space-time. So we know what it does, and we know that the majority of the universe is made out of dark energy. But exactly what is it? We don't know that yet. So the instrument needs to make the largest ever three-dimensional map of the universe. This is the way we're going to learn more about dark energy.
So this instrument, the Dark Energy Spectroscopic Instrument, it has the ability to measure 5,000 different galaxies, all within about a 3-degree field of view, all at once. It measures their spectra, which means it takes the light and it splits it up into many different wavelengths. And from that fingerprint, we can tell how far away these objects are. NOIRLab is the National Science Foundation's laboratory for optical and near-infrared astronomy, ground-based astronomy. It's been our job to maintain the telescopes, make sure the operations go smoothly, etc., and keep them operating every night. The thing that makes DESI possible is this rather remarkable feature in the early universe. So very early in time, right after the Big Bang, the universe goes through a very rapid period of expansion called inflation. And after that point, the universe is extremely smooth, but it has tiny little perturbations in density, and those perturbations grow. And it's those ripples, these sort of spheres in the universe, where we have a slight overdensity of galaxies. So DESI tries to make a measurement of these spheres in the sky, basically from the present day back in time to about 12 billion years, and try and map how these spheres have changed. And that's what we call our standard ruler.
So what we can do is create computer simulations of basically a simulated universe. So if we want to simulate, let's say, 5 or 10 different universes with each a different version of dark energy or different versions of gravity, each will predict different 3D structure. And then we can compare with the real observation that we do with DESI to basically determine which model is correct. If dark energy is constant, which is the model we've had in mind for 25 years, it means that the dark energy is the same, which means that the acceleration of the universe expansion would continue forever. It means that all galaxies become so far apart from each other that it's impossible to even see another galaxy. But if dark energy does get weaker with time, it could be that the expansion of the universe slows down eventually. So instead of being always accelerated, it could stabilize. And the more extreme case, it could slow down to the point where it stops completely expanding and collapse onto itself again. So it's this balance between matter and gravity going one way and dark energy going the other way that will dictate the final location of all galaxies in 3D in space-time. So with DESI, we made an initial measurement, and we actually had a surprise that no one was expecting on the team, which is that dark energy seemed to deviate slightly from being a constant, meaning that dark energy is changing or evolving. And in fact, there's a possibility that dark energy is weakening with time.
The results have been fabulous. I mean, we couldn't have hoped for a more interesting time. So this acceleration is slowing down. It doesn't mean we've started decelerating. It just means that we're accelerating more slowly. So there's been a change to how the acceleration has changed with time, which is different from what we thought back in the late 90s. So what does that mean? It means that the future of the universe is sort of up for grabs.
One thing that I find hard to wrap my mind around myself, even as an astronomer, is really the sheer distances. It's just the immensity of the universe. It's beyond anything that we, experience as humans. And thinking about this, even if it's my job, is still sometimes a challenge.
We often think that astronomy is an old field and we know a lot about the universe, but in reality, we're very much in a discovery mode.
This nation has the resources to undertake such exploratory ventures.
Perhaps this universe will expand forever and slowly get fainter and further away. If the universe manages to turn around and we go back through another oscillation, well, it would be a different kind of an end for everything that currently exists in the universe. But for science, there has never been a final answer. It's always been a new horizon that we want to get to or understand. It's the mystery that keeps you going, and finding the answer to the mystery is incredibly satisfying, whatever that answer may be. I think we have a lot of mysteries that we're trying to solve, and that in itself is an incredibly exciting thing to look forward to.
As I mentioned at the top of the program, Kitt Peak National Observatory is packed with telescopes and projects and science going on. And joining me now is the operations manager of the Kitt Peak Visitors Center, Peter McMahon. Thanks for having us in, Peter. It's a wonderful place, as anyone who's been here knows. Tell us about it.
Yeah, Tom, so we're inside the McMath-Pierce Solar Telescope, which until recently was the world's largest solar telescope. It's no longer used for science currently, but instead of just retiring it, we put a science center in it. And as far as we know, this is the world's first science center inside the actual structure of a telescope.
And it's huge. It will soon have a new title now as far as being among the biggest and the best. Tell us about that.
Yeah, so aside from Mount Wilson's telescope in California, when we get the main optics of this solar telescope working again, we've got the auxiliary ones working already. When we get those main optics working, after that other telescope, this will be the world's largest telescope for public outreach.
Nice. In the broader scheme of things, a lot of what goes on here at Kitt Peak has had huge ramifications in the science world, space world, going back years and going forward. Tell us about that.
Yeah, and there are a lot of observatories here where researchers have done work over decades that have paved the way for other discoveries and other achievements here and beyond. Today, there are telescopes and instruments that are creating the largest, most detailed 3D map of the universe, discovering and measuring exoplanets, planets around other stars. And this telescope, the McMath-Pierce, back in the 60s and 70s, and so was used for discovering things about solar oscillations, discovering water on the sun, water vapor, and it was used at nighttime to view bright objects in the solar system, such as the moon. Even got used by the Apollo astronauts to plan and train for their moon landings.
Exactly, I was going to bring that out. Now, this was a pivotal part of our early space exploration.
The control room tables that we project sunlight onto and moonlight these days were surrounded by a circle of astronauts that included at times Neil Armstrong, Buzz Aldrin, Michael Collins, Jim Lovell, Apollo 13 Jim Lovell, and all sorts of other pioneers who went to the moon, in part because of what they were able to learn at this telescope.
Okay, Peter, so one of the highlights of our visit right here.
This is the crown jewel of the Windows Center, as we call it right now. The Windows on the Universe Center Science Center is the control room, and it's in here that researchers used to take the light of the sun down onto these tables here and analyze the light spectra of the sun. Today we do that for fun, and I can show you that right now.
Sure. Yeah, I'd love to see it.
So this is the live webcam view of the optical element called a heliostat, more than 100 feet above us. And I've opened that up. I'm just going to move the telescope over to, there we go.
Oh, wow.
So we're now looking at the live view of the sun through what once was the largest solar telescope in the world. It's the dimensions of the Statue of Liberty, if you include the pedestal the Statue of Liberty is on. And that light is coming down a massive tunnel down onto this table here where we can see sunspots, cooler areas of magnetic disturbance, so those little dark islands.
Yeah.
The sun itself is about 5,500 degrees. And then those black areas are significantly cooler than that. And those gray areas that are sort of feathering out beyond some of those black areas are in between in both temperature and intensity of magnetic disturbance that's happening there.
That's what the sun looks like real time we're looking at now.
This is what the sun would look like if you were in a spaceship and went to the sun and could filter out 99.99%+ of the light and not, damage your eyes or get vaporized by the heat of the sun. This is what you would see out your spaceship window.
I think this is preferable to what you described. Yeah.
So each of these little tiny dots is bigger than the Earth. The medium-sized ones are dozens of times, or more than a dozen times the size of the Earth. And the really large sunspots there, just to give you an idea of scale, would be, off the top of my head, dozens and dozens of times the size of the Earth. The whole sun is 1,000,000 times the size of our planet.
Why is it important for everyone to know at least something about what's going on at Kitt Peak?
I think a lot of what we discover, what researchers discover here, and the personal discovery you can do for yourself on guided tours and evening public telescope tours where you can look through telescopes here, speaks to a sense of wanting to know about who are we, where did we come from, where are we going, what is the nature of existence, of the universe. And so I think it's great to be able to have so many opportunities for not just scientists, but the public to come here and be immersed in that day and night.
So Peter, you're an hour outside of Tucson. A lot of folks make the trip. What kinds of things can they expect to see and do out here?
Well, it's definitely worth the trip more than ever to come out here. We've got a new science center that we've just opened, but also day or night, you can spend the whole day here. We even have some people who do day tours and then stay for the night tours. But you can do all or some of those. We have tours of a number of active major research telescopes during the day that our docents can take you through and guide you through and answer questions about. We have evening tours where you can come and look through some of our large visitor center telescopes. And we also have an overnight program where you can essentially be like a visiting astronomer and you get the full experience where you get your own guide, your own observatory to yourself.
Peter, thank you again for having us in. We appreciate it. We're excited and love seeing everything you have to offer. This is great. Thank you.
All right, my pleasure.
Well, you obviously won't find them in outer space, but down here in the desert, there are thousands of endemic and desert-adapted plants that would do well in your garden. And if you're looking for an intriguing and beneficial tree, the experts say check out the Netleaf Hackberry. You'd be getting a native plant with obvious benefits for people, pollinators, and other wildlife.
We're here at the Children's Museum of Oro Valley at Tohono Chul Gardens. And today we're going to talk about this lovely tree that I'm standing under, the Netleaf Hackberry, Celtis reticulata. This tree is typically found in riparian areas, basically canyons or washes, from about 2,000 to 6,000 feet across the Southwest and as far north as eastern Oregon. What I really love about this tree is that despite it being from wetter parts of the Southwest, places that get about 18 inches of rain or have seasonal water through them, it's really quite drought tolerant and will perform really well for us here in Tucson. I've seen these trees growing out of cracks and sidewalks, and they're really ideal for folks that are using water harvesting basins or swales to capture street or roof runoff or using gray water from their houses. And if you're into attracting wildlife into your yard, there are few plants that will do better for you. There are dozens of species of birds that are known to associate with this tree as a nesting habitat or a food source. This tree produces orange berries with sort of a cantaloupe flavor, and the berries persist on the tree often well into the winter time, providing a really valuable food source for birds like cardinals, wrens, thrashers, and phainopeplas. It's also a really great tree for butterfly caterpillars. So there are several species that will eat the leaves of this tree without doing any significant damage. The leaves have sort of a sandpapery texture, and they have really distinctive veins as well. But one of the things that I think is really neat about these leaves is that they are a host for a number of species of gall-forming flies. So these flies have no real negative impact on the tree, but these insects are going to provide an additional food source aside from the berries for all of those birds that you're going to attract to your yard with this tree. This tree is deciduous, so it will drop all of its leaves in the wintertime. However, it has this really interesting and distinctive steely gray bark that develops a knobby, interesting texture that gives it visual interest year-round, even when it doesn't have leaves on it. One of the other great qualities of the hackberry is that it lacks thorns. So it makes an ideal street tree. It can be pruned up to the 7-foot canopy height that the city of Tucson likes for street trees so that folks can pass under it without having to stoop. And without thorns, they aren't going to be catching themselves on it. I have this tree planted on the south side of my house where it can provide shade in the summer, and when it drops its leaves, it allows more light in the winter time. So it's a great tree for passive heating or cooling in our arid climate with those extremes of heat and cold. Fortunately, people are becoming much more aware of the incredible diversity of native landscaping plants here in southern Arizona. And so this tree used to be fairly uncommon, difficult to find in nurseries, but it's increasingly available for homeowners, landscapers, and public works projects. And over the next few years, you'll start seeing a lot more of these trees around Tucson, creating the type of shade that's going to help mitigate the urban heat island effect that can make Tucson a pretty difficult place to be in the summertime. All around, this is one of the best powerhouse wildlife trees for Arizona yards.
If you're interested in learning more about desert plants from experts and our producer, Tony Paniagua, join us Saturday, February 28th for a Thriving in the Desert, Creating a Sustainable Tucson. This live event will be held from 2 to 4 p.m. in the Environment and Natural Resources 2 building on the University of Arizona campus. For more information, go to azpm.org/thriving, and we hope to see you there. Next, we take you from the Sky Islands of southern Arizona all the way up to northern Arizona to meet a traditional Kachina Doll carver, and you'll see how the practice has helped to sustain him and his family.
My name is Cory Ahownewa from the village of Hope. I do the traditional style Kachina dolls. The reason why they're called traditional style is everything's used from the earth, all the way from the cottonwood root that I go out and pick in the Colorado River, and pigment paints that I go and collect throughout the Hopi reservation. I've been getting my cottonwood root on my own down in the Grand Canyon doing the cultural preservation river trips. I've been doing this for a little over 25 years. Ever since I was probably 4, I seen my family members doing the artwork. My whole family are artists. Charles Loloma, that's my uncle. He's a world-renowned jeweler. You can make money with your hands and be self-employed, work your own hours. This is a good job for me. People needed a way to make a living, so then that's how selling Kachina dolls came about. Probably like the 1920s. It was used for our ceremonies first. The Kachinas are spirits. They were here before the humans, that they roamed this earth before us long ago. After they passed on, they live now at the San Francisco peaks. It was a volcano then. It's called Novatokyaove, the mountain with the snow on top. That's what it means in Hopi. So that's a very sacred place for the Hopi. Not only us, all the different tribes throughout the Southwest. I would make a doll, go up to Tikashovi, go sell it for 120 to 150. Then I would just drink all that money up. Then after I had my son, then it dawned on me, all this stuff that we're using to make money for ourselves, it's all from the Mother Earth is giving us this resource to take care of ourselves and not to be using it for negative things. That helped me to get on the sobriety. And my son never seen me drink. Riley, we call him Honani, badger boy. I told him, hi bud. Yeah, he's just turned 9, and thanks to my son, he what did you wish for on your birthday?
For the baby to come early.
Yeah.
So that happened?
Yeah, when he blew his candles out. Her name's Elizabeth. She ended up coming 6 days after his birthday. This one's gonna be the badger, the Honan Katsina. The badger, he lives in the earth and he talks to Mother Earth, and Mother Earth showed him all the different plants for medicines. This is the Coancoyamsi. I got the inspiration from going down the Grand Canyon in the monsoon time. When we go down the Grand Canyon and it rained on us for like four days. Then after that 4th day, then everything started blooming. And this Kachina, it represents when the monsoon comes and all the plants on the earth, they start blooming and they start showing all their color. And so that's why this has a colorful Kachina. Coancoyamsi is the handsome mudhead. And the paints, these are all from the earth pigment paints that I go out and pick. All this is all part of nature, doing this type of artwork. Being one with the earth and partaking in our ceremonies and giving thanks for this Mother Earth giving us all these resources.
Thank you for joining us from Kitt Peak National Observatory. I'm Tom McNamara. We'll see you again next week. Hi, I'm Tom McNamara, host of Arizona Illustrated. Thank you for watching this entire episode of our show here on YouTube. And if you liked it, well, here's another episode that we think you'll like.